Good afternoon. We're going to be focusing on three things today. Very quickly, finding the function's inverse, verifying that two given functions are inverses of each other or not, and then working with literal equations, which are just formulas. Find the function's inverse, quick and easy. Find your y, in this case g of x. Replace y with x and x with y. So basically we're going to swap the variables. So x equals 2 times y plus 1, the quantity cubed, minus 4. The next thing we're going to do is solve for y so it's back in function form. So we're going to add 4. We're going to divide by 2. Could also take it times 1/2. To undo the cube, we're going to do the cube root. Since the cube root, you can take positive or negative cube root. You do not have a plus or minus. Okay, so we're not going to deal, when we do that cube root, we're only going to do a positive cube root. Okay, so undo that scribble, and that's going to cancel our cube and leave y plus 1 equal to that cube root, and ultimately we'd have y equal the cube root of x plus 4, that quantity divided by 2, and then minus 1. So that's y equals, since a cube passes a horizontal and vertical line tests, g would have an inverse that is a function, so we can actually call it g inverse of x in function notation. Otherwise it would just be a relation rather than a function. So ultimately we have g inverse equals this cube root and then that minus 1. So that's it in a nutshell. Swap x and y, solve for y, change to function notation. Alright, so the next thing we're going to do is we're going to look at two functions. We are assuming they are inverses of each other. If they are inverses of each other, we should be able to do the composition of functions f of g of x and g of f of x, and both arrive at just x. It's important that we go both directions, because sometimes you'll find one of them will undo another. They'll not be complete inverses of each other. So with that in mind, because of domain restrictions, so with that in mind, we're going to start with f of g of x. So we're going to do f of g of x, and g of x is 3x plus 4 over 2. We're then going to go find function f, and every time we see an x, we're going to replace it with function f. Now this is going to look ugly, but if they are inverses of each other, it should start falling apart in our laps. So we have 3x plus 4 divided by 2. So our next step is we're going to start simplifying. Our 2's are going to cancel. We'd be left with 3x plus 4 minus 4 all over 3. But 3x plus 4 and minus 4, those two sum to 0, and we're left with 3x over 3, or x. If that had been anything but x, we'd say these are not inverses. Now we need to reverse this process. So we're going to find g of f of x, and we should also get x. Very important we go both directions. So we're going to find g of f of x is 2x minus 4 over 3. Oops. Okay, we're going to go and find function g, which is 3x plus 4 over 2. We're going to replace that x with 2x minus 4 over 3. We are going to start simplifying. It should start just falling apart in front of us. That's 2x minus 4 plus 4 over 2. We can see those are going to sum to 0 and leave 2x over 2, which is x. Bottom line, we verified that f of g of x and g of f of x both give us x back out. With that in mind, anything you fill in is going to give you that number right back out, so they're undoing each other, so they're inverses. If it's any other result, if you'd gotten x plus 2 instead of x, you'd simply say no inverses. Once you decide there's no inverse going one direction, there's no reason to do the other one. Our final topic of the afternoon is working with literal equations. Literal comes from the word literary, as in words and letters. So in this case, a literal equation is basically a formula. It has pretty much all letters or a lot of variables. So in this case, we're going to solve for h, and you'll notice we have an h, in this case 2 h's, on one side of the equation. So since they're both h to the first, I have two separate terms that contain h. Terms, remember, are separated by addition or subtraction. We are going to see, since we can't combine those as like terms, we're going to see if we can factor out that h. So we're going to factor out an h. We do that, we'd be left with pi r squared plus 2 pi r in parentheses. Since we're solving for h, and h has been multiplied by that quantity, we simply need to divide both sides by that quantity. We'd add, so pi r squared plus 2 pi r. Okay, difficult to write in that small of space. This is considered entire factor, so that factor divided by that factor yields 1. So you are left with h equals a divided by that entire quantity, pi r squared, plus 2 pi r. And that, ladies and gentlemen, is how you solve a literal equation for a particular variable. A lot of different algebra skills involved, otherwise it's just manipulation.